Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss application of derivatives. Okay, my dear children. In this chapter, we are going to discuss the sums in the exercise 6.5. Okay, my dear children. Page number 231 in the textbook. Page number 231 in the textbook. Are you ready to listen the class, my children? Right. See the question number 1. Question number 1. Find the maximum and minimum values, if any, of the function f of x is equal to 2x minus 1 whole square plus 3. Understood this question, my children? Please remember this point, my children. For every function, there is no compulsion, there is no compulsory that f of x has maximum as well as minimum values. Sometimes f of x has only maximum value and sometimes f of x has only minimum values. Okay, my children. Sometimes f of x has both maximum value as well as minimum values. Okay, my children. Right. So, to find the maximum or minimum values of this function, there are two methods. I am explaining the two methods only for the first question. But in the examination, you need not write the two methods. Only one method is enough. Only one method is enough in the examinations. Okay, my children? Right. Now come to the method 1, first method, without using the concept of derivatives. How to find the maximum and minimum values of the given function. Okay, my children, let us discuss this point. Let us write the given function f of x is equal to 2x minus 1 whole square plus 3 for all x belongs to R. This is the given function. We have written in this step. Understood this step, my children? Right. We know that 2x minus 1 whole square is always greater than or equal to 0 for all x belongs to R. Do you know this fact, my children? Because whole square, see this one, see this expression, whole square is there. The square of any numbers, the square of whatever this real number, whatever the number it is, we are taking here square. Square of any real number is always greater than or equal to 0. It never be a negative number. It may be a 0 or maybe a positive real number. Okay, my children, we have to use this fact. Okay, my children, right. Now we are adding 3 on both sides of this equation. Then what will you get here? 2x minus 1 whole square plus 3 is greater than or equal to 0 plus 3. Understood this step, my children? Just we have added 3 on both sides of this inequation. Then we got to this step. Understood this step, my children? Right. This implies if you observe LHS, it is nothing but f of x. Isn't it or not, my children? 2x minus 1 whole square plus 3 is nothing but f of x. So I wrote in LHS, instead of this expression, I wrote here f of x. Understood LHS, my children? Right. Greater than or equal to. Come to RHS. What will you get in RHS? 0 plus 3, 3 only. Understood this step, my children? Because f of x is equal to 2x minus 1 whole square plus 3. By using this result, we got this step. Understood this step, my children? Right. Means f of x value is always greater than or equal to 3. It means f of x has minimum. Therefore, we can say that f of x has minimum value. And the minimum value of f of x is 3 only. For any real number x, f of x value is always greater than or equal to 3. So, f of x has minimum and the minimum value of f of x is 3. When it occurs 2x minus 1 equal to 0. Okay, my children, if it is equal to 0, that is by solving this equation, what will you get? X value 1 by 2. Understood this step, my children? So, if x is equal to 1 by 2, then f of x is equal to 3. This is the minimum value at x is equal to 1 by 2. Understood this point, my children? Understood this step? Right. but f of x has no maximum value because f of x tends to infinity as x tends to infinity. So in this case f of x has no minimum value. F of x has only minimum value. F of x does not have maximum value because f of x tends to infinity as x tends to infinity. Understood this point, my children? Right. If you draw the graph of f of x, it looks as follows. Y is equal to f of x represents a upward parabola as shown given below. See here, my dear children, I am representing this function graphically. Then you can easily understand this concept. See here, in this Cartesian plane, by taking some values, and we get here this is a graph of y is equal to f of x. If you observe what is the minimum value here, at this point f of x has a minimum value. At x is equal to 1 by 2, it has f of x value is 3. This is the minimum value, and there is no maximum. It is going towards upwards infinitely. We can't find its maximum value. It has only minimum value because it is upwards parabola. Okay, my children, understood this concept, my children? The maximum values and the minimum values of this function f of x, my children. Minimum value of f of x is 3 at x is equal to 1 by 2, but it has no maximum value. Understood, my children? Right. Now come to the method 2, second method, using the concepts of derivatives. Using the concept of derivatives, we are going to find the maximum value and minimum value of this given function. Okay, my children? Right. What is given here? F of x is equal to 2x minus 1 whole square plus 3. This is a given function we have written. Okay, my children? Right. Please remember these steps, my children, carefully. Right. Step 1. First step is we have to find the derivative of the given function. That is the first step. Okay, my children. In finding the minimum value and the maximum value of a given function, we have to find f dash of x. This is the first step. Okay, my children, all these steps comes under the step 1. Okay, my children. So differentiating with respect to x, what is the differential operator then? D by dx. So I wrote d by dx, the differential operator d by dx on both sides. This implies d by dx of f of x is equal to d by dx of 2x minus 1 whole square plus 3. Understood this step, my children? Right. This implies, come to the LHS, d by dx of f of x. How do you write this notation? What is the value of d by dx of f of x? Yes, f dash of x. This can be written as f dash of x, or we can say that the value of this one is f dash of x. Okay, my children? Understood LHS? Right. Is equal to, come to RHS. We have to find the derivative of this function. If you observe this function, it is having two terms. The first term is 2x minus 1 whole square. This is the first term, and plus 3 is the second term. So we can find the derivative of this function by finding the derivatives of the two terms separately and adding them. So we are finding like that. So d by dx of 2x minus 1 whole square for the first term, just like a distributive property. Okay, my children, just like a distributive part, d by dx of 2x minus 1 whole square plus d by dx of 3. Understood this step, my children? RHS part? Right. This implies f dash of x, I wrote LHS as t, is equal to, now come to the first term. How do you find the derivative of this function? Yes, we have to compare this function with d by dx of x power n. In our mind, we have to assume that 2x minus 1 as x and n is 2. So it is in the form of d by dx of x power n. So what is the derivative of this function? 2 into n into x power n minus 1. So 2 into 2x minus 1 whole power 2 minus 1. What will you get? To 1 only. So I am not writing here 1 as power. Understood this part, my children? Right, into d by dx of 2x minus 1. Understood this part, my children? Why we have written this one? Because we assumed 2x minus 1 as x in our mind, so we had to differentiate that function also. Understood this part, my children? Right, plus come to the second term, d by dx of 3. What is the value of d by dx of 3? 0, because there is no variable, only constant. So d by dx of any constant is 0. Understood this term, second term, my children? Right. Understood this statement, children? Right, because d by dx of x power n is equal to n into x power n minus 1. d by dx of constant is equal to 0, and also we have used chain rule to get this step. Understood this step, my children? Right, this implies, come to LHS, we write LHS as it is f dash of x is equal to, come to the RHS, 2 of 2x minus 1 into, again we have to differentiate this function. If you observe, again we use the distributive property, so d by dx of 2x minus d by dx of 1. Understood this part, my children? Understood this step, my children? Right, this implies we wrote LHS as it is f dash of x is equal to 2 of 2x minus 1 into, we have to differentiate this function. If you observe this function here, 2 is a numerical coefficient. We have discussed that point many times, my children. Several times we have discussed. If there is a numerical coefficient, we can write it before the differential operator. Then we differentiate the remaining part. So d by dx of x. After writing this 2 before the differential operator, what will be left here? X only. So d by dx of x. Understood this first term, my children? Right, minus d by dx of 1. If you observe this function, it is a constant function. So d by dx of any constant is 0. Understood this statement, children? Because d by dx of constant is equal to 0. By using this result, we got this step. Understood this statement, children? Right. This implies we wrote f dash of x, LHS as it is equal to 2 of 2x minus 1. We wrote this part also as it is in RHS into 2 into, come to this part, d by dx of x. What is the value of d by dx of x? 1. Right. We are not writing this one, plus 0, minus 0. We can omit. We can delete that part. Understood, my children? 2 into 1. That's all. Because d by dx of x is equal to 1. Understood this step, my children? Right. This implies f dash of x is equal to 2 into 2, 4 into 2x minus 1. This is f dash of x. So in the first step, remember this step 1, my children, we found f dash of x. Okay, my children? Understood? Right. Now come to the step 2. Step 2. In this step, we are going to find f double dash of x. In step 1, we have found f dash of x. In step 2, we are going to find f double dash of x. For that, we are again differentiating with respect to x. We get d by dx of f dash of x is equal to d by dx of 4 into 2x minus 1. Understood, my children? For the previous step, we are again differentiating with respect to x. Then we get this step. Okay, my children? Understood this step? Right. This implies, see, LHS d by dx of f dash of x. What is the value of d by dx of f dash of x? Yes, f double dash of x. We can denote this entire part as f double dash of x. Understood, LHS, my children? Right. Is equal to, come to RHS. If you observe this function here, 4 is a numerical coefficient. So we can write it outside before the differential operator. Understood this part, my children? Right. Into d by dx of, we have to write the remaining part, that is 2x minus 1. Understood this part, my children? Understood this step, my children? Right. Because d by dx of f dash of x is equal to f double dash of x. By using this result, we got this step. Understood this step, my children? Right. This implies we wrote LHS as it is, that is f double dash of x is equal to 4 into, we are going to find the derivative of this function by using distributive property. So d by dx of 2x minus d by dx of 1. By using the distributive property, we got this part. Understood this part, my children? Right. Understood this statement, children? Right. This implies f double dash of x is equal to 4 into. Again here 2 is a numerical coefficient. We are writing numerical coefficient before the differential operator d by dx. So 2 into d by dx of what is the function left here? X only. Understood this part, my children? Right. Minus d by dx of 1. What is the value of d by dx of 1? 0, because it is a constant function. So d by dx of any constant is equal to 0. By using this formula, we got this step. Understood this step, my children? Right. This implies f double dash of x, we wrote LHS as it is equal to 4 into 2 into, what is the value of d by dx of x? 1. Understood this part, my children? Understood RHS, my children? Right, because d by dx of x is equal to 1. After using this formula, by applying this formula, we got this step. Understood this step, my children? Right, this implies f double dash of x is equal to, what will you get by simplifying these numbers? 4 into 2, 8, 8 into 1, 8 only. So finally we got f double dash of x value is 8. It is a positive real number, isn't it or not, my children? Yes. If f double dash of x is greater than 0, then we say that f of x has a minimum value. Remember this point, my children. If f double dash of x is greater than 0, then we say that f of x has a minimum value. On the other hand, if f double dash of x value is less than 0, if the f double dash of x value is less than 0, then we say that f of x has a maximum value. Remember this point, my children. Okay, my children? Right. To find the point at which f of x has minimum, we have to solve the equation f dash of x is equal to 0. By solving this equation, we can find the points at which f of x has minimum. In this stage, we are finding critical points or turning points or stationary points. This is nothing but step 3. Okay, my children. In step 1, we found f dash of x. In step 2, we found f double dash of x. In step 3, we are going to find critical points or turning points or stationary points. Okay, my children. Remember these steps, my children. So this implies we have to solve f dash of x is equal to 0. We have to solve this equation to find critical points or turning points or stationary points. Okay, my children, you know this point also. We have already discussed in the case of increasing and decreasing functions. Okay, my children, we have solved it. F dash of x is equal to 0. Okay, my children. Right, this implies what is the value of f dash of x? 4 into 2x minus 1. We have already found it, so we are writing that value here in LHS is equal to R 0. We write RHS as it is because f dash of x is equal to 4 into 2x minus 1. Understood this step, my children? Right, this implies we are sending 4 to RHS. It becomes 0 by 4. In LHS, 2x minus 1 will be left. So 2x minus 1 is equal to 0 by 4. Understood this step, my children? Right. This implies 2x minus 1 is equal to 0 by any number. We get 0 only. Understood RHS, my children? Understood this step, my children? Right. This implies 2x is equal to, we are sending minus 1 to RHS. We are moving minus 1 to RHS. Then it becomes plus 1. So that is equal to 1. Understood this step, my children? Right. This implies what will you get x value? We are sending 2 to RHS. Then it becomes by 2. So 1 by 2. Understood this step, my children? Right. Therefore, we say that at x is equal to 1 by 2, f of x has minimum value. Okay, my children? We got a critical point at which the given function has minimum value. Sometimes we get more than one value for x. So at that values we can say that f of x has minimum value. Okay, my children. Now step 4. For finding the minimum value of f of x, we have to substitute this critical point. Whatever the points we got, whatever the values we got here, by solving f dash of x is equal to 0. We got only one value, x is equal to 1 point. critical points or turning points or stationary points in f of x. We have to substitute these values in f of x. Then we get the minimum values or maximum values of f of x. Understood this point, my children? Right. Then we get f of 1 by 2 is equal to 2 into 1 minus 2 into 1 by 2 minus 1 whole square plus 3. Understood this statement, children? We have substituted x is equal to 1 by 2 in f of x is equal to 2x minus 1 whole square plus 3. In the given function, we substituted x is equal to 1 by 2. Then we got this step. Understood this step, my children? Right. Now we simplify this expression. This is equal to 2 gets cancelled. Then what will be left here? 1. 1 minus 1 whole square plus 3. That is equal to, understood this step, my children? Right. That is equal to 1 minus 1. What will you get here? 0. 0 whole square plus second term we wrote as it is plus 3. Understood this step, my children? Right. That is equal to, what is the value of first term? 0 square? 0 only. Plus we wrote second term as it is plus 3. Understood this step, my children? Right. Now by simplifying these two terms, what will you get here? 3. Okay, my children, this is nothing but, this number is nothing but the minimum value of f of x. Therefore, the minimum value of f of x is equal to 3. So finally, we can say that f of x has minimum value 3 at x is equal to 1 by 2. Understood this, my dear children? Right. So if you want to use the derivatives concept to find the minimum value or maximum value of f of x, you have to follow these 4 steps. Okay, my children, I repeat that 4 steps. What are the 4 steps? Step 1, find the derivative of f of x. That means f dash of x. Find f dash of x in the first step. Step 2, we have to again differentiate f dash of x. Means we are going to find f double dash of x in step 2. In step 2, find f double dash of x. Okay, my children, understood? Right. Now step 3, find critical points by solving the equation f dash of x is equal to 0. Find stationary points or critical points or turning points by solving the equation f dash of x is equal to 0. That is step 3. And step 4, for finding the minimum value or maximum value of f of x, substitute that critical points or turning points or stationary points in the given function. Then we get the maximum values or minimum values of f of x. Understood these 4 steps, my children? Follow these 4 steps, whatever the question given based on the concept of maximum values, finding the maximum values and minimum values of a given function. Okay, my children? Right. Now come to the question number 2. Question number 2. Find the maximum and minimum values, if any, of the function f of x is equal to 9x square plus 12x plus 2. Understood this question, my dear children? We have to find the maximum and minimum values, if any there exist. We have to find the maximum and minimum values of the given function f of x is equal to 9x square plus 12x plus 2. So for this question, I am following the first method. You can follow second method also. Both methods are correct. Okay, my children, as per our convenient, we can follow any method. There is no compulsory, there is no compulsion. Okay, my children, right. Given function, come to the solution part. Given function f of x is equal to 9x square plus 12x plus 2. This is a given function we wrote here. Understood this step, my children? Right. This implies f of x is equal to, we are trying to write this algebraic expression. This is a quadratic expression. We are trying to write this quadratic expression as a perfect square. So this number, this first term can be written as 3x whole square. Isn't it or not, my dear children? Right. Plus we are writing this as 12x second term as 2 into 3x into 2. Can we write it or not? Yes. So we got here a square plus 2ab term. We got two terms. Then what will be third term? B square. What is b here? 2 plus 2 whole square. Actually there is no 2 whole square, so we are adding this term and subtracting the same term. Then there is no change in this expression. We are adding the term and subtracting the same term, then the value of that expression does not change. That is why we are adding this 2 whole square minus 2 whole square, and finally we are writing that last term plus 2 as it is. Understood this step, my dear children? Because we are trying to write this quadratic expression as a perfect square. That is why we are writing this step. Understood this step, my children? Right. This implies f of x is equal to, if you observe these three terms are in the form of a square plus 2ab plus b square. How can we write this expression? Yes, a plus b whole square. These three terms can be written as a plus b whole square, where a is equal to 3x and b is equal to 2. So we wrote like this. Understood this term addition 3x plus 2 whole square, right? After that, these two terms are left. Minus 2 whole square. What is the value of minus 2 whole square? 4 plus 2. We wrote these last two terms as it is, because by using this algebraic identity, a square plus 2ab plus b square is equal to a plus b whole square. We used this algebraic identity. We applied this algebraic identity to get this step. Understood this step, my children? Right. This implies f of x is equal to, we wrote the first term as it is. By simplifying these last two terms, what will you get? Minus 4 plus 2. Yes, minus 2 only. Understood this last term, my children? Right. So if you observe this function here, perfect square is there. So we know that 3x plus 2 whole square is always greater than or equal to 0 for all x belongs to R. In the previous question, the first question also we wrote the same steps, because square of any positive, any real number is always greater than or equal to 0. We never get a negative number. So we wrote this step. Understood this step, my children? Right. We are subtracting 2 from both sides on this inequation. Then we get 3x plus 2 whole square minus 2 is greater than or equal to minus 2. Understood this step, my children? Right. This implies, if we observe this LHS, it is nothing but f of x, 3x plus 2 whole square minus 2. So I wrote f of x instead of this expression in LHS. Understood, my children? LHS. Right. Greater than or equal to, what will you get? 0 minus 2. What is the value of 0 minus 2? Minus 2 only. For all x belongs to R. So if you observe this statement, f of x values are always greater than or equal to minus 2 for all x belongs to R. Okay, my children, because f of x is equal to 3x plus 2 whole square minus 2. By using this result, we got this step. Understood this step, my children? Then we can say that f of x has a minimum value, because the values of every function, every value of this function is greater than or equal to minus 2. So it has a minimum value. Therefore, minimum value of f of x is equal to minus 2, which occurs when this value is equal to 0. 3x plus 2 is equal to 0. Understood this step, my children? That is, we are finding the value of x by solving this equation. Then x is equal to minus 2 by 3. Understood, my children? Right. This is the minimum value of f of x, that is minus 2, when x is equal to minus 2 by 3. At this point, f of x has a minimum, and the minimum value of f of x is minus 2. Understood, my children? Right.